Hey guys, let's get right into it. We're about 2 hours away from the new year, so I think we can fit in a quick video real quick, right before the New Year's. If you hear some banging noises, some pops and some bangs, it's because we got the neighbors going. They're partying outside, blowing, popping fireworks and all that good stuff. All right, here we go. Let's get right into it. And we're going to be utilizing the two formulas from yesterday, guys, or from part one and part two. You don't necessarily have to watch those to understand this. Just understand that one is like 100%. So we're talking about money here. So it's compounded interest. That's why the plus symbol's there. The N stands for how often it's compounded. And then the T, well, because we're talking about how often it's compounded within the year, the T has to be in years. But we'll see. We have a bonus problem here where you're going to see that the T is not going to be, you'll see what I'm talking about. Because they're all related. All these are all exponentials. So they're all related, guys. Okay, let's get right into it. Example one, and I probably already said let's get right into it, quote unquote, like 3 or 4 times, right? Alvarez is going to invest in an account paying an interest rate of 6.5%, so that's your R, compounded annually. So if I compounded annually, that means it's compounded once a year, so that's your N. How much would Alvarez need to invest to the nearest cents for the value of the account to reach $41,000 in 13 years? So here's the amount that we want, and here's the time duration that we want it. So we're going to just use our formula, this one right here. We're going to go 41,000. 41,000 equals, and then the P, that's what we're trying to figure out, what the initial amount is, 1 plus 0.065, that's what 6.5% is in decimal, move the decimal 2 times to the left, divided by 1, but it's itself there, right, times 1 times 13, so 13. So there it is, guys, and then obviously, we're going to divide by whatever this is, so figure out what this number is, and I think I have some previous junk in here. Yeah, I think we're about to hit it up. All right, so here we go. So we're going to do 1 plus 0.065. Yes, I know that is literally 1.065. I'm going to raise that to the 13th. Bam, and there it is. That's the number that we're going to use. So right now we have 41,000 equals P times, I already forgot that number, 2.26748. But use all of them, guys. 2.26748 ... That just means it keeps going. I'm going to divide by that number to get P by itself. So P equals 41,000 divided by 2.26748. And it keeps going forever, guys. So use the number stored in the calculator. So here we go. I'm going to use the fraction feature. I'm going to push enter, and I'm going to put 41,000 here in the top. 1, 2, 3. And that was my last output. That's an answer. So I'm going to put second ANS, and there it is. It's going to be divided by this number right there. And there it is, guys, 18.081.6. Round this up, 9. 18.081.69. 18,081.69. In case you're wondering, why didn't I use a comma over here or here? Sometimes I get confused and I put those as decimals when I know they should be commas. So I don't put it initially, but if we're talking about money, you should probably put a comma there to indicate 18,000 is the initial. So Alvarez, if you want 41,000 in 13 years, you have to invest 18,000 initially, well, $18,081.69. If it's being compounded at 6.5%, compounded annually. So hopefully that was cool, and you can see it's pretty straightforward, nothing crazy. All right, let's see what we got here next. Pircello is going to invest in an account paying an interest rate of 4%. So there's your R, compounded continuously. So if I'm compounded continuously, guys, I'm going to be using this equation, PE to the RT. How much will Pircello need to invest to the nearest dollar for the value of the account to reach 15,000 in 5 years? All right, so this is the amount I want. There's the time. So 15,000 equals the initial amount, E raised to the rate, which is 0.04 times T, which is 5. All right, so I'm going to type this into the calculator. So E to the 0.04 times 5. And I guess you can change it to 0.2, I guess, right? 0.04, 0.04, 0.04. All right, 0.04 times 5. That's your 0.2, yeah. So E raised to the 0.2. E raised to the 0.2. And there it is. And so what we're going to do, so we got 15,000 equals P times, and again, we got 1.2214 1.2214, 1.22140. And I'm going to divide by that. So the initial amount, let's see, 15,000 divided by 1.22140. And use the number that's in the calculator, guys. So let's see, what do we got here? I'm going to go alpha, enter. I'm going to put, was it 15,000? Yeah, 15,000, 15000. And I'm dividing by second ANS, and voila, 12,280. I think it did say to the nearest dollar amount. Let me see, to the nearest dollar. So 12,281. 12,281. So 12,281. And yep, sure enough, yay, 2 for 2. All right, let's go to another one, guys. Mazuka is going to invest in an account paying an interest rate of 6.3%, compounded daily. So compounded daily in a year, that's 365 days. We're not talking about a leap year, just a regular year. How much will Mazuka need to invest to the nearest $10? The nearest $10 for the value in the account to reach 77,000 in 12 years. So 77,000 equals the amount that we're going to be looking for, 1 plus 0.063 divided by 365 to the power 365 times 12. So there it is. I'm going to do, sorry guys, the coffee. I had some strong coffee. So I'm going to do that in my calculator. And I'm going to do 77,000 divided by that right there. So let's see. I'm going to first figure out what this number is. So I'm going to go 1 plus alpha fraction, enter, 0.065. That's 6.5%. Nope, 6.3. So 6.3%. Let me delete the 5 and put a 3. Divided by 365. And close it. And it was raised to the power 12. So 365 times 12. So I'm going to go power 365 times 12. I'm going to push enter. And there it is, 2.1296. So let's see. 77,000 equals P times 2.12. Did I say 96? 960. 2.12960. 2.12960. And of course that goes on forever, right? And again, just the same thing as the other ones, guys. 77, I don't like how I wrote that 7 there. 77,000 divided by 2.12960. And it keeps going forever. So here we go. So I'm going to go 77,000 divided by, so I'm going to go 77,000, and this time I'm just going to do it like this, divided by, and I'm just going to scroll up, push enter, and there it is, 36,157, 36,157, 36,157, so 36,157, that's the dollar amount, but it did say up here to the nearest $10, so we're going to round up, so the amount, 36,160. And there it is. Yay. All right. Let's do a bonus question, guys. This is not about money. This is about decaying. And I just want you guys to see that they're all the same, especially if they say that it decays exponentially, right? A quantity with an initial value of 7,800 decays exponentially at a rate of 2%. So there's your R. So 2%, which is the same thing as 0.02, every 3 years. So every 3 years. I need to write it down. I know it says it right there, but I need to write it down. What is the value of the quantity after 4.7 decades? Well, why do they say 4.7? Why can't they just say 47 decades, right? T equals, let's see, 4.7, and there's 10 years in a decade. So 47 years. So they're just being funny, guys. All right, so let's do this. Let's do this. All right, so let's see. What am I going to have? Amount equals the initial amount, 78,000, 7800, oh, I said 78,000 again, 7,800, parenthesis 1. Now, I'm not growing. This is decaying. So 1 minus 0.02. Chav, you're not dividing by how often it's compounded. Well, that's every 3 years, guys. So this is why I told you the end doesn't necessarily have to be here. So I can just write it like this, T over 3. See? There it is. Every 3 years, if I put that 3 there, this is going to be to the power 1, and I'm going to have 98% of it left. So hopefully that made sense here, that this is just your 98%. That's how much you have left, right? After 3 years, you have 98% left. So every 3 years, you're going to have 98% left of that amount. So this will work, see? So if I put a 6 there, the t equals 6 years, 6 divided by 3 is going to give you 2. So there it is. That's 2 iterations of that's 2 cycles, because it does, one cycle is every 3 years there. So I hope that makes sense to you guys. So 7800 times 0.98 to the power t over 3. And I'm going to type in 47 in there. And it does say to the nearest hundreds. The answer is down there. Oh, I kind of already saw it. Hopefully, I don't remember it, guys. I haven't done this one yet. So hopefully, we don't get embarrassed here, or I don't get embarrassed. Let's see. So we're just going to type that in, and that should be our answer right there. So let's see, 7,800 times 0.98, because that's how much you have left, to the power, and we said 47 over 3, because that's going to tell us how many cycles we've been doing, guys. How many 3-year cycles we've done. So hopefully that made sense. And there it is, 5683.7. That's the nearest tenth, or nearest, let me look at it again. Nearest hundreds. So nearest hundreds, you're going to go to this guy right here, because the 9 is the thousandths. So you're going to say 0.77. So 5683.77. 5683.77. And there it is. And let's see if we got it. Yay, we did, guys. So hopefully that made sense to you. Why did we put that 3 in there? Because this is how often, that's what one cycle is, quote unquote, for this dude, for the exponential decays. It's every 3 years. So that's why I told you in part 1 in the video, sometimes they include the n in the exponent, sometimes they don't. So it just depends on the situation, guys. All right, I hope that you guys like that. Hook it up with a thumbs up if it all made sense. Let me know if it didn't make sense. And Happy New Year. I'll probably come out with part 4 at the beginning of the new year, guys. All right, see you guys later. Bye.